Welcome back. This is an Aleks training video on relating vapor pressure to vaporization. So, vapor pressure, when a liquid boils, all of its liquid turns into gas. But if you have anything less than the boiling point, some of those atoms or molecules will gain enough energy to escape into the air. And what will happen is that the gas version of that liquid will sit above that liquid. So imagine a glass of water, and you put it on the table, and over days and days, the water just evaporates. What will happen is, as they're evaporating, the gas will sit on top of that water. So you'll have a glass of water with liquid, and then above that water will be some gas water vapor sitting there. And there is a temperature, there is a pressure in the atmospheric pressure. And as soon as you can go over that or reach that atmospheric pressure, it's boiling. That's what boiling means. So boiling means you've got the vapor pressure is equal to the atmospheric pressure. Okay, so if you have a temperature less or pressure less than the vapor pressure, more of the molecules of the liquid will gain energy and escape. If you have a pressure higher than the vapor pressure, then more of that vapor will condense back into water. So what you've got is a graph of it's the vapor pressure with temperature. So anything on that line is going to be the same amount of escape and the same amount of condensation. So the rate of turning into a vapor is going to be exactly the same as the rate of condensing back into a liquid. So look at the picture at the bottom for a second. So I've got a couple vessels. I've got some ethanol, some alcohol in a vessel, and then eventually what's going to happen is it's going to exert a pressure because some of that liquid is going to turn into a gas. So you're going to get gas, and it's going to bop around, and that bopping around is causing a pressure. So the vapor pressure is the pressure caused by the gas version of that liquid that's sitting above the liquid. Okay? Now check out what I've written here. The liquid and the vapor reach a state of equilibrium. You're going to turn, there's going to be just as much coming out at the vapor pressure. You're going to have just as much escaping into gas as you have going back into liquid. They're going to be the same rate. Okay, the same rate. So that's the vapor pressure. The vapor pressure is when it's turning into gas, the same speed as the gas is turning back into water, okay, or liquid. Now they're asking you several questions here, so I have to give you some definitions. First of all, I gave you a definition of the vapor pressure here at the top. So the vapor pressure is the pressure exerted by the atoms in a gas directly above its liquid. So the push that gas is pushing, that's the vapor pressure. Okay. Now look here. A substance boils when its gases overcome the atmospheric pressure, and that's 760. 760 torr is 1 atmosphere. Okay, now I guess it could change day by day. The weather usually tells you the barometric pressure. That's millimeters mercury. You could change it into torr easily, but normally 1 atmosphere is the pressure that something is going to boil. That's normally at sea level. Okay, now check this out. The term volatile, if you've ever heard of a volatile liquid, like gasoline is a very volatile, it doesn't mean that it's going to explode. Gas is volatile, will explode, because what will happen, the liquid gas evaporates very, very easily. It evaporates so easily that you could have lots of vapor of gasoline above a gas can or something, and then those gases could explode. That's how you usually use the word. If something's like if a person's volatile, they'll explode. That idea. So volatile just means easy to evaporate. Okay, so if you have a high vapor pressure, then more of that liquid is turning into gas. If you have a low vapor pressure, it means you've got lots of intermolecular holding, so it's really hard for them to turn, like they're holding each other like Velcro. They have intermolecular attractions. So if you have very low intermolecular attractions, say like gasoline, which is a covalent bond, it's just a molecule. It's not polar, it's nothing like that. It'll easily escape into gas. But if you have something with lots of hydrogen bonding, like water has a very low vapor pressure, and so it doesn't escape very easily. You could have a glass of water on the table for days and it would still be water. Okay? It would take a long time to completely evaporate everything. So they're going to ask you some questions and I'll try to answer them. Okay? You may have to go over this video a few times. First question they ask is, which liquid is the most volatile? Okay? So that means which one evaporates the easiest. Okay? So which one reaches 760 torr earlier than the other ones reach 760 torr? So if we look at the schematic here, you've got, say, 760 torr is up here. That's a red line that I've drawn. That's 760 torr, that's atmospheric pressure. Which one reaches atmospheric pressure at a lower temperature? Well, this guy reaches, here's 760 torr at like 111, but these guys are like, 136 or something and 144. So this one's going to have, this is the most volatile. So the most volatile because it's it evaporates the easiest. Okay, so I would say the most volatile is going to be the toluene. Okay, so the toluene evaporates fastest, so it's most volatile. Which is the least volatile? Okay, well that would be the black one. The black one is the orthoxylene, whatever. Don't even know what that is. Next question is, what is the normal boiling point? Well, the boiling point is when it reaches 760 torr. So I tried to draw a red line there at 760 torr. You're going to have to kind of eyeball it. And then go down from that point to the bottom where it gives you the time. And to get this right, you have to be within 1 degree Celsius. Okay. Now the grid here is going to be, let's make it bigger so you can see. The grid at the bottom is in ones. So this is 110, 111, 112, 113, etc., all the way up to 120. So like this red line is between 110 and 111. I would round it to 111. But you have to be either 110 or 111 or 112 or it's going to count you wrong. So I guess it doesn't matter if you would round it down to 110 or round it up to 111. I don't know. I would round it up. This hit right on 120. Or I'm sorry. No, the next one, sorry. That's black. The other red line I have is the green, the ethylbenzene. And so I'm just going to count up from 130. 130, 1, 2, 3, 4, 5, between 5 and 6. Okay, I probably would say 5. It may be 6, I don't know. And then the next one is 140, 1, 2, 3, between 3 and 4. I'd probably say 144. Okay, so those would be the boiling points. Okay, so let's put this back. What's the boiling point of orthoxylene? I think we said 144 Celsius. The ethylbenzene, I don't know, 135 or 136. I don't know, it's closer to 135, I thought, maybe. I don't know. One of them or the other one. And then the toluene's the blue line. It was just a little bit between 110 and 111. I would say 111. Okay. Now, suppose a beaker of ethyl benzene is put inside a sealed tank containing ethyl benzene gas at 120 degrees and 471 torr. Okay, so let me show you the picture one more time. At 120 degrees, that's the black line. So I drew a black line straight up at 120 degrees, and 471 torr, I drew a line here. And it hit right on the line. Since it hit right on the line, remember, is the same amount going into liquid as going into gas. So if it's the same amount, then that's the vapor pressure at that temperature. Right on the line is the vapor pressure. So if the vapor pressure, if it's above the vapor pressure, more will come out as liquid. If it's under vapor pressure, more will go out as gas. But if it's right smack dab on the vapor pressure, then nothing will change. Okay, so you would want, when we go back to this, if it's right on it, this is going to stay the same. Okay, this is, I think, the longest video I did this year. Okay, so I hope it helped you.